Hi guys, welcome back to another video. Today we're going to be looking at the AMC 2017 problem number 10. And here we have a view of the problem. And it reads as follows. A box contains 5 cards, numbered 1, 2, 3, 4, and 5. 3 cards are selected randomly without replacement from the box. And we are asked, what is the probability that 4 is the largest value selected? Okay. So just to make sure we understand the question, we reach in and grab 3 random cards, and we want to find the probability that of the 3, the largest value is a 4. So basically we don't want to pick a 5, and we want to make sure that we pick a 4. Okay, so there's a couple ways that we could approach this. First of all, the numbers are quite small, where you could do just some quick listing and you should get your answer. And we will do that solution, but let's start with maybe a little cleaner solution. So the idea here is the probability that, the probability that 4 is the largest number we pick. That's just the number of ways that 4 is the largest divided by the total number of ways to pick 3 cards. So how many ways is 4 the largest? So for this, what we want to do is you basically have 1, 2, 3, and 4. And of this, we want to pick 3 of these numbers, right? But 4 has to be one of them. So in other words, we basically already picked 1 card. It has to be a 4. So out of these 3 cards, we want to pick 2 of them, right? So now some of you may know this we could just represent as 3 choose 2, right? Because out of these 3 cards, we pick 2 of these, and the order doesn't matter. So we can just write this as 3 choose 2. And our total, similar lines, we have 5 total options, right? 5 cards, and no restrictions. So we just want to pick 3 of our 5 cards, right? And just as a quick review, 3 choose 2 and 5 choose 3, this notation, so these are called binomial coefficients. And this basically means 3 choose 2 would be calculated as 3 factorial divided by 2 factorial times 3 minus 2 factorial, right? So this is just 6, which is a numerator, right? 3 factorial is 6. And then our denominator would be 2 factorial is 2 times 1 factorial is 1. So this would be 3, the top half, the numerator, right? And this basically means that you have 3 ways to pick your first card, 2 ways to pick your second card, and basically 3 times 2 is 6. So that's the idea of these coefficients. And then same thing in the bottom, 5 choose 3, that's just 5 factorial divided by 3 factorial times 2 factorial, right? 5 minus 3, so 2 factorial. And now this is what this is basically. If we write this out as in product form, so we can kind of see what we're looking at, 3 times 2 times 1 times 2 times 1. So 5 choose 3, if we cancel this out, this is basically just 5 times 4 divided by 2, which is 10. And so therefore, our probability is just 3/10, right? The numerator we got was 3, the denominator was 10. So 3/10 would be our final answer. And this is indeed the correct answer. So this is one option that we have, right? And if, say, you forget how to do binomial coefficients, or maybe you don't know this notation, you could always list this out too, because the numbers are pretty small, where you know the total. So if you have 1, 2, 3, 4, 5, right? So say we kind of start fresh. 1, 2, 3, 4, 5. If we start with calculating the total is just, I need to pick 3 cards out of these 5. And so how would we do that? If I have to pick 3 cards, right? Say these are my 3 undetermined cards. I have 5 options for my first card, right? So say I pick a 3, for example. Now I have 4 options for my next card. Say I pick a 1. And then I have 3 remaining options, right? It could either be a 2, a 4, or a 5 for my last card, and say it's a 4. So basically you have 5 times 4 times 3 ways to pick 3 cards. But notice here that a 1, a 3, and a 4 is the same as a 1, a 4, and then a 3. which is also the same as a 3, a 1, and a 4. And so basically, there's 6 ways to arrange our 1, 3, and 4, right? If we quickly list it out, I have 1, 3, 4, 1, 4, 3, 3, 1, 4, 3, 4, 1, and then 4, 1, 3, 4, 3, 1. Right? These are 6 different ways that I could pick the same 3 numbers. And we don't want to count this 6 times. We only want this counted once. So we would do 5 times 4 times 3, but then divide by 6. And this is just, again, 10, right? And we already found that from the last half of this. But we know now that why we use this 5 choose 3. So 10 is our total. And now to find the number of sets of 3 numbers where 4 is our highest or largest digit, we can just list this out, right? Because 1, 2, 3, 4, these are really these are the possible values I could use. I know 4 has to be in each one of my arrangements. So I could do a 1, a 2, a 4, a 1, a 3, a 4, or a 2, 3, 4. And there's nothing else, right? This is 1, 2, 1, 3, 2, 3. These are combinations of 2 numbers out of the 3. And so this is a total of 3 possibilities. And this again gives you your 3/10 value that we found above, right? 3 right here, and then 10 as our total. And that concludes this problem. So if you enjoyed the video and you'd like to stay updated with new videos we upload daily, and liking or subscribing really helps us out. But anyways, I will see you again tomorrow for another video. Thanks for joining.